Hello, I'm Paul Weiss, and I would like to talk to you about my solar thermal heating panel that I built. Finished completion recently this fall during COVID season. This is the one that you see upper left-hand side of this house here. My commercial panel's on the lower right-hand side of the house. Um, I want to talk to you about how the thermal heating panels work, why I chose this design, and how I built this, and how you could build it, and roughly the costs for building it, and issues I ran into, and things that could be improved. Um, but yeah, so let's dive into this. I have a solar powered house you could see here that I'll talk about in another video, but I have solar electric. I have thermal air heating panels, and I also have solar hot water system. So kind of every kind there is. Um, and I'm pretty much off of fossil fuels. So let's dive into this panel and how it started and why I chose this. I first want to show you, this is the finished panel set here, why I chose this design. There are a whole dozens of designs on the internet for what they call soda can heaters, thermal air heaters. And many of them are good, but I tried to look through a whole host of them and really get the concepts that make it for the most powerful heating unit and the least cost and easiest to build. There's a balance, of course, but I really tried to get it so it would work well. And basically, you're designing a giant wooden box or metal box, whatever you want to make it out of, and then you're insulating three sides of it, um, the side walls and the bottom, and then you are putting in your absorption area, which is, these are made out of cans, the soda cans. You can use other stuff. There's other designs on the internet using downspout pipes from gutters, aluminum downspouts for houses. There's other metal sheeting that they use. But this design, from what I can understand and read, was the most energy absorbing efficient. In other words, it produces the highest heat output. Um, this part right here, this section's on the lower headers and the upper headers, is also aluminum. That's just flashing aluminum. So it's where all these cans are coming in and where they're open. So these can rows are hollow. I'll show this to you later how they're made, but top and bottoms are hollow and they're all connected by being glued together with silicone. And these header areas are are aluminum flashing. So they're really doing the same as the cans. They're just a place for all the air to collect. Now there are separate boxes. I made really three heaters that are connected, but essentially they work the same way. This is mounted on the side of the house, and this would be the top on this end, and this would be the bottom on this end. In the air, there's a hole on the reverse side of this, on the underneath part, where the air from the house, which you usually mount low in a bedroom, it's in my bedroom, comes in, and then it goes two ways. It can either go across this whole header, or it can start coming up each of the rows of cans. So the air's coming across and it's coming up all the rows of cans, and as it does that, it's heating up because the sunlight's hitting it, and these are black cans and they're aluminum, which is highly conductive of heat. And they're being drawn by a small fan that's up in this unit right here. Now this is I'll show this to you later, but there's a small 12-volt computer fan that draws the air into this upper header. So all of the air is being collected at the end of all of these can rows into this upper header, and all three panels are connected. And so the air is being drawn in this direction and then into this box here, and then it's being exhausted out back another hole that goes into the house, and that's in the same bedroom, kind of a little higher up on the wall towards the ceiling. And that little fan is powered by this small photovoltaic panel. So a little 12-volt photovoltaic panel. Now there's lots of other concepts in here that are a little nuanced, but some really, I guess the biggest important concept to this soda can heater or the aluminum heaters are, you really, if you want to get high efficiency, you have to put either glass or Lexan or plastic over the whole unit. The whole reason you get really high temperatures is because you're making this layer underneath the glass a dead air space. And that dead air space really is an insulative layer and is heating up also. But the sunlight is really heating the cans. And so you're really getting a much, much higher temperature. If you did not have this glass on over the cans, you would get some heating, but it would be pretty low, like probably in 70, 80 degree mark. Whereas with the glass over this, sealing this entire unit and having that dead air space as a vacuum, essentially, I got temperatures over 200 degrees Fahrenheit. So it makes a huge difference having this piece sealed off. And also, you'll just lose less heat. It'll be much more efficient. It's absorbing a much higher percentage of the sunlight. And that's the same basic way that solar hot water systems also work, is with basically an evacuated tube that has a layer of air under glass, and then your heating elements. So it's using the same basic concept as the solar hot water system that I could show you in another video on my house. But this is really the best way to go as far as the efficiency. There's other heaters that people just don't put any cover over it, and they work okay, but not even close to what this thing puts out. When you're doing, when you can put out over 200 degrees, that's, just boiling water temperature. So it's extremely hot and very, very efficient. So that's one of the basic key concepts. There's another concept on how you cut the can top and bottoms off. I just cut the tops off, but how you punch a hole through the bottom, there's a whole bunch of different ways to do that. There was some studies done on how to do that. I'll show that to you later, but I used the most efficient way. And so this is the basic design. It is the sunlight heating that air underneath, inside those cans, which is already under a layer of glass, and that hot air just being exhausted straight into the house. One last thing, just as the design of using glass, I would recommend using glass over plexiglass or plastics or Lexan, because it'll just last a lot longer. It won't fade or crack or break after a period of time. It's just a lot stronger and it'll last for decades versus years on the other stuff. So it does add a lot of weight to it. That's the only bad thing, but it will last much, much longer, and it's a much better way of having the sunlight penetrate it. Once upon a long time ago, I did actually make these plans for the two panels, really 3 panels, and really the size and dimensions were primarily based upon the size glass that I got. The glass that I got was for free. It was being thrown out, and they were double pane glass. I'll show that to you later, and that's why I designed it that way. And so I bought materials, to make the wooden boxes, basically 3 wooden boxes with that glass. This is some of the foam, foil-backed polyacrylate foam, and wood thin back. Really, construction was making these boxes with squares, framing squares, and screwing them together. I didn't do any fancy joints, just pretty much a straight square joint, and just used wood screws to get them together. Again, these panels were just sized to the glass, about the size of the glass that I got for free, and they were double pane glass, so I separated them. I just used regular wood screws and didn't do anything fancy on the joints, just straightforward. I did use a nice little nail gun that I had on the back to get the wooden panel onto the back of the frame, which was nice to use. It's kind of fun. I don't think I've ever used this tool, but I had purchased it a long time ago, so I finally got to use it, which is a good thing. And they kind of just look like gigantic boxes, almost like furniture that you're making. Nothing really fancy to it because it's purely utilitarian. I made one panel bigger than the other so that it could fit the extra solar panel, photovoltaic panel, and also the box for the fan. This is the panel that I bought from Harbor Freight, just a 5-watt solar panel. You can buy them pretty easily on the internet. And the fan was a 12-volt computer fan from Radio Shack. And these are just how it went together. Again, really nothing that fancy being built here, but important to get all your dimensions proper so everything fits in and is sized correctly. This was the larger of the two panels because it had the fan and the solar panel unit that powers the fan. I did put an on-off switch in the room to turn this on and off in the spring, but it's pretty much powered by the sun. When the sun's out, it turns on. I just leave it on all winter from like November to April. The foil backing, this polyacrylic foam, has a foil backing. Put the foil facing, and I put it facing the panel, the cans, even though it was painted over. It can do a little bit of radiative heat. So this I put on the entire back, including behind the panel and behind the fan. It's just another layer. You really want to do, if you can, at least a 1/2 inch, if not more, of foam, because it's what's keeping the heat into the panel. So this is the hole that goes into the house with the 12-volt blower fan. And this, again, is just really like a computer fan that was connected to the panel. And these are the header rows that my friend Rick let me use his drill press, and I cut out these holes that were for the headers so that the cans could rest, the ends of the can columns could be held by those holes. So I was building sort of headers so that all the rows would come together. Again, these columns of cans are like a hollow column, and you can see then the air would go up the rows of cans and come out the top all heated, and then be blown into that header row. So I needed to get the fan installed in this little box. I finished the other box off with foam backing just to make sure that it's really can keep the heat down on the inside the box. I just used some little corner brackets to hold the solar panel right on the surface. I didn't want to bury it deep in there so that the sun could actually get at it on the surface. The header rows were connected with this 4-inch gigantic drill, hole drill, just like the can rows, which were actually a little smaller than 4 inches. I forgot what a can is, but whatever the diameter of a can is, a little bigger than that. And so that's how the header rows are put in over on top of the insulation. And so the whole thing was insulated at the bottom. I needed to put this fan into the box and somehow secure it to the hole into the house. So I used a little dryer vent that I got from the hardware store, Ace Hardware, and just cut it out so that it fit. And I drilled it into this little hole and I just glued it with silicone all the way around. So really nothing too complex about it. But I did do it that way so that if I needed to ever replace that fan, I could do that. Um, Not sure, how long the fan will last. Probably 5, 10 years, maybe. Um, Maybe more, maybe less. It's hard to say, but if I had to get at it, that's why I made this box, and I later put a hinge on it so I could get at that fan. I insulated everything all the way around the box. That's the hole that goes into the house. So on the upper part of the panel, that'll blow into the house. And I used a laundry dryer vent hole. Again, just a Radio Shack fan, 12-volt Radio Shack fan powered by the solar panel. So all the panels were connected to one another. I did build them separately, two, a large one and a small one, and the small one sort of had two sides to it. This is the drill that I used to drill through the headers, which was a pain in the neck, but it worked. So that's between the panels, how they're connected. And because I was mounting them separately, because these things weighed a ton, I needed to have this aluminum in there so that I'd sort of have a guide to connecting the two wooden pieces together. So I put a little 4-inch hole there. I used the same type of material that you use for dryer vents, clothes dryers. And then I just put it in and glued it. I cut it around with a 10 snips and just connected the holes together. So it became one long header that went through 3 panels. So again, one on the bottom end of that, this is the glue to glue it in. It's going to be cold air coming in from the house, from the bedroom, the lower part of the bedroom, and then it will go up the rows of cans and be heated, or into the next header section. So nothing too complicated about it. It was important to seal everything with silicone because I didn't want any air getting into the dead air space. And the foam, on some parts I got to use a 1-inch foam. On the back I think I used 1/2-inch foam. You can get this insulating foam at Lowe's or Home Depot or any building supply store. I then started painting it, putting a base white primer on it to just seal the wood and make sure that I could get it ready for the high temperature paint that I painted the box with. Here you're seeing sort of the mess of what it looked like for a long period of time. This project took quite a while because I kept stalling and procrastinating. And the fan box I built with hinges, and so you could get into it, and that inside, so you could see it was completely insulated. I mounted that dryer vent and the wiring coming from the solar panel, and then a wire going into the house so I could turn it on and off if I needed to. But basically that is the inside of the fan box. And as you can see, these things are taking shape. I started painting the black of the headers and also the base. Then I needed this aluminum flashing for the headers, and I used, this is just like gutter flashing, house flashing that you can buy in rolls. And I used that drilled down into the headers, and then the other end was glued against the wood with just silicone. I did have to bend this. I put a slight fold in it, and I also bent the aluminum so that it would hold against the wall. Everything I sealed was silicone, all the corners. So the inside box was airtight. It really was sealed, including these headers were sealed with. So these headers silicone. Were aluminum, and they were a little bit below the level where the glass would come in, so I had to keep a gap there. I then started painting the base of the inside of the box, and then after I painted, I sealed it. This is high temperature, flat black paint that is fairly expensive, so I did use a lot of it up. But again, this area can reach temperatures well over 200 degrees, and so it's important to use this. It's the kind of paint you use on wood burning stoves. It's a flat black paint, and it does cure. It takes a while to cure, and it'll take several months of heating at temperature to cure, to dry completely. It dries to the touch and everything, but it does take a little while to cure the paint, and you might get a tiny bit of a paint smell if there's any leakage between the cans and the box, which hopefully there isn't, but there might be a crack or something, or a tiny bit of it. So you can get this at any hardware store. It works pretty well. It works great on wood stoves, but it works great here. The aluminum that I use, again, is this roofing flashing, and it comes in sheet rolls, and you can use a good tin snips, like a Wiss tin snip, and cut this aluminum. It's almost as good as the aluminum cans as far as header absorption. But this is kind of how I bent it. I had to put folds in it, and this is a cool metal bender that I had gotten at Harbor Freight years ago, and I finally got to use it a few times. It's really nice. You kind of just hold this metal bar in place, and it puts a nice fold onto this material. Once it's folded and bent like that, you've increased the strength, and it holds together well. This is just a big metal thick bar, and so that was put in right here. Now, one thing I will say, this silicone that I used, you can see it's kind of weirdly colored and kind of chunky. Well, I had some old silicone in my basement that my brother had given to me years ago, and I decided to use it, which was a huge mistake, because this silicone does expire, and it had expired. So this was old silicone, and it was really bad. It never dried. Even though I used a hair dryer on it, it just didn't cure properly. So I had to actually take all of this silicone and wipe it all clear, clean everything apart, clean it all up, and then re-silicone it with a silicone that was actually not expired. So I learned my lesson well. Don't use expired silicone or paint or things like that. It just doesn't work. It really just, you can spend hours, which I did, having to redo something that I shouldn't have done. I learned my lesson, but I learned it the hard way. Again, if you're going to spray like this, I had a fan going in the window right a few feet from this, so the paint was not going into my lungs. It was going out this window. But as you can see, it takes a lot of paint to cover an area like this well. Here you can see the headers, the aluminum headers before they were painted, where the cans would go, and all sealed up, so there's no air that can get out anywheres. And inside those boxes, it was sealed with good silicone, so that's completely air sealed. And so I had to do that before putting the header, aluminum header on. So even in the header area that is getting the air into it is going to be a heating area too, because the aluminum will heat up. So here all the headers are done. One side is painted, the other side's not painted. And I also will say that I finished painting it, and then I had to start thinking about the glass and how to get that on. This box, I painted the outside. It was going to be against a wall. I put 2 coats of paint on it. There you're looking at the inside of the header where all the cans will be sticking into. And those, again, were glued. Everything was glued. Here's the stacking. This is actually just a little thing that I made to stack the cans when they're glued together, and I had to get a number of them ready. I'll have a video of that in a minute. I put handles on all four corners of both panels, and this made a huge difference. I had to add this little extra ridge here for the cans for give it support because the columns were too long, so I added this little foam strip. Again, with the high temperature spray paint was painting the whole thing. You can see the handles that I put on for weight, and the first row of cans going in, so they sat in like this, and they were glued to that center strip of foam. It really added some strength to the overall can columns. So you try to clean out cans. These have been washed. And I got a lot of cans in there. I washed these with bleach, a little bit of bleach, some soap and water, and I did a few rinses on them. Some of these cans are new, but some of them, a lot of them were from the streets of Cumberland, and that's why I got them, because they were junky cans. So this is how we take a can. Lift up the tab. Sometimes they break well, other times they don't. And that's that. Recycle it. Empty it out. So, take a can. Corona. It's called a stepper bit. One hole. Two holes. Three holes. Again, this design with the three holes was found through research, from what I could gather, to be the most efficient, best way to make holes in the cans. They did an experiment with different types of holes, the different numbers of holes, and different sizes, and this was found to be the best. In other words, it created the most air disruption in the columns to promote the thermal exchange of heat between the air and the aluminum. So these three or four holes per can, about this size, was the most efficient thermal method. So instead of cutting the whole can out, it created this little Venturi effects and some heat exchange. So basically I'm using GE Silicon Advanced waterproof, and it's 100% silicone, 25-year warranty. It's the best stuff, but it's about $10 a tube. How I do this is I run a bead right around the top, right where the two cans meet. No matter what you do, you got to do this twice. And that's it. against the rack. Make sure it's pressed in and down. Now the can columns, I found that after I had glued them a single time, weren't strong enough, and there was also some gaps once in a while. So I ended up having to glue each of the columns again after it was built, and I put it in place, which was a major pain in the butt, and it took a lot of extra time. But adding the extra layer of silicone in between each can really made a big difference. It made sure there was completely sealed, the columns were completely sealed, and it also added a lot of strength to the columns, so they seemed a little bit flimsy with just one gluing. So this really really strengthened the columns. They were really rigid after this, and I didn't need to worry about the columns ever coming apart or if I moved it or something. So even though it took a lot of extra time, and it also took a lot of extra silicone, and it was messy, it did fix the problem I was having, and it seemed the best way to do it. I was then gluing the columns of cans into the headers. Now the headers were again drilled out with a hole saw, and I really needed to get a really thick bead of silicone all the way around the headers, the holes, because you really wanted to have that sealed. It was a messy job. It wasn't too much fun, but as you could see, I did get silicone all over the place. I probably used 10 tubes of this silicone, so that's $100 worth of silicone alone. It was a lot of silicone. I think my hardware store liked it. And then for strength, I glued that midsection down so that when I put the whole column of cans in, it was glued at the top, at the bottom, and then the middle. And then again, each column had been re-glued. You can see I also started putting in some black spray foam on the end, that insulating expanding foam, as another seal, but I don't know, I did a little bit, and I found that I really didn't need to do it. It was sort of a waste. I did have some problems getting the bottom part sealed of these columns, but it was just a matter of playing with it and doing work and getting it in there. You had to get one in first, and then get the other end in, and then seal the bottom, and hopefully, and then I ran an extra. Once the column was in here, you could see I'm putting an extra bead around the cans just so that it was sealed. I really wanted to make sure this was sealed because this is the two air spaces. The airspace in the cans is completely separated from the airspace between the glass and the cans. And that's important because that's where your thermal barrier is, and that can increase your temperatures by well over, I'd say, 80 to 100 degrees better heating by having a completely separated glass panel. I mean, that's the greenhouse effect put in a nutshell. You're seeing the big difference between what a greenhouse can do and what it can't do. So again, the glass preparation for this, the glass was again from the that I had gotten for free, and you could see below here is the doubled panel that I actually had to separate out into two separate sheets. I actually had totally different sheets, and that's what I used for the paneling. Here's one sheet that I had separated. You could see the edges still have glue on them, which wasn't a big deal, but it was important to try to clean it as the best I could. I used a razor blade and glass cleaner and really tried to get the panels as clean as possible on both sides. I didn't do a perfect job, but you want to get it clean because otherwise it's going to fog up a little bit because there's always moisture that can get in there, and then it condenses, and it condenses on the dirty parts of the glass. So you end up getting these weird streaks, and it's a little frustrating. So try to clean it, I would say 3 times with glass cleaner, and non-lint paper or newspaper works really good. But really clean it as best you can with the razor and with the glass cleaner. Does work pretty good. This was trying to get the two pieces of glass apart that were double paned. On this one, the one piece had broken and I just had the frame left. But you can see this is one of the pieces. I used angle aluminum stripping around the edges to hold the glass down. You want to be able to have that glass float in there. So I put this angled aluminum, as you can see, as the framing that was drilled into the side, and then the glass was sitting upon some foam, which you'll see in the next. There needs to be expansion room for the glass to move a tiny bit when it heats up, and that's why I use this aluminum that's screwed in on the side and not the top, and the glass could actually float to a certain degree underneath that frame, even though it was solidly in there. This is double-sided tape, or foam, really foam. It's gluey on one side actually, not double-sided. Using this Armstrong, this is for a drop ceiling, angle irons for drop ceiling. I'm just screwing it in with these self-tapping screws. So after getting all the glass on and the framing, the glass framing, the panels were pretty close to being done. I did put silicone on the outside of the screw holes to seal that, and I painted the framing black, which was hard to do, but pretty much you have a black stealth frame. Here's the three panels together. Kind of gives you an idea what it will look like on the side of the house. Everything is painted, sealed, the glass is on, and again it's free floating. I even sealed up with silicone the door to the fan just for the time being. If I need to get at it, I can cut it out. The outside installation was a lot harder than I thought it was going to be. The panels ended up weighing like really a lot each, like 70 pounds. I used these angle brackets into the frame of the house to mount it, and I used a stud finder to do that. You can see getting it leveled and making sure it was lined up properly was important. I had to buy scaffolding from my house, so I bought 2 layers of scaffolding, which was very expensive, about $800. So this was not a cheap project, but I will reuse it. On my house, it had this kind of fake facade thing that was pushed out of the house, and I had to mount it a little bit away from the house because of that white strip that you could see angles through it. We used, my brother-in-law and I helped, and we got it up on the scaffold with 2 ladders, hoisting it up. I was down on the lower ladder, and he was pulling it from the top, and it was 2 full layers of scaffolding to get that thing up there. It was quite a project. It really took a whole morning to do it, to get it on there and make sure everything was done. Drilling the holes through the house was the scariest part because you don't really want to drill, make sure they're lined up, and I had to measure everything twice, 3 times, and again, drilling 2 holes in the house was the scariest part of the whole process. But it did eventually work, and I'm glad I bought the scaffolding. just wanted to show you how we're going to connect the solar panel into the house. And that's using a hole saw, 6-inch hole saw. It's always fun cutting through your own house. Fun stuff. And for the outlet, this is a dryer vent with a flap, as you can see, that will open up on, with gravity. I mean, it'll close with gravity, and it will open up when air is flowing out. So that's going to be coming from the solar panel into the house, and we're going to mount that high. That's the upper one. And then on this lower one is just an intake vent. Now I've modified this intake vent, and I took this little screen off, and I put in a little piece of filter. You can get this at any hardware store, and I put Velcro along here, along all 4 edges, so that filter will filter out some of the dust in the air and prevent it from going into the solar panel cans, and it'll just keep the air clean. And if it gets dirty, you just take it out and change it. You can buy a whole stack of these for like $5. It'll last you a few years. Just a thin cover. So that's the modified intake. The last piece was installing these through the house. You could see I drilled through the wall, but I also added wiring to each of them that I wired through the wall. And these are the for the thermal sensors. So I needed a little thermal sensor that connects to a computer, and I'll show you that later in the basement. But I put thermal sensors in the intake and the outtake so I could get real-time temperature measurements on the whole system to see how well it's working. And so this one on the intake was really just measuring room temperature, but that's the thermistor right there, the little sensor, and I just hooked it up. Here's the vent. Let's see what temperature. This is a 180-degree temperature. 181 degrees. Give you an idea how hot a hot air dryer can be. And on a record day, I got over 200 degrees. That's seen on this temperature sensor. So over 200-degree temperature. I'm going to go through this on another video, but my whole system is connected through a bunch of controls by Full Gauge. It's a Brazilian company, and these temperatures are monitored. Part of that software that controls it's called SITRAD, and this software is really great. I'll go through it in another video, but this is the output on a good day, like mid-November, early November, of the system. And you can see the graph, the bell graph of the curve here is the heating temperature of the output, and the top line is almost 200 degrees. So you can see, the outside temperature was pretty cold for that day, and it's outputting at close to 200 degrees for several hours of the day. So all told, on my solar house here, it was a good system to put on. It did take a lot of time, and it cost around $1,000 to build because of all the paint and glue and silicone and stuff that I had to purchase for it. So it wasn't a billion times cheaper. The commercial units are about double or triple that price, to give you an idea. So I did save some money. I mean, it'll cost you around $6,000-$8,000 for a commercial unit of this size. And it probably, cost me obviously about $1,000, so it's a lot cheaper if you don't count my time. You're looking at my electric system, my solar hot water, and then the 2 commercial heating units that are on the side of the house here. So these system, it really worked well. Actually, what I built outproduces my commercial unit by many degrees. It outperformed it. So the unit works great and will save me a lot of money over the years. If you have any questions, please email me. Thank you.